Hi, welcome to this second video on Atmel AT88SC102 secure memory card. I'm DC here. In the last video, we just saw an overview of this memory card, and from this video onwards, we are going to see this card in detail. These are some of the requirements in order to use this tag. First of all, you must have any reader writer that supports this particular memory card. I'll be using AT88U, and there's also one more, the contact cards from the ACS, which is AT39U. And if you look at the numbering, this looks like the later version of 138U. However, this card does not support the Atmel AT88SC102 memory card. So if you're thinking of buying a new reader writer, I would advise you to buy the AT38U, which supports almost every feature of AT39U as well. There's one more reader writer which also supports this memory card, that is ACR1281U, and this is a dual interface reader writer, because keep in mind this is a contact memory card, and if you buy 1281U, this comes with both contact and contactless interfaces. So you have to get a copy of this data sheet, and also you have to get a copy of the command set of ACR38 or ACR1281U. So I've shown this document in my previous video. The first one is the document you get with the reader writer. You can download this from the manufacturer site. And this one, this is the data sheet of the SC102 memory card. Now we have covered some of this theory in the previous video. However, I thought it's good that we go through this quickly so that you understand this video better. Now there are two types of operations that are defined in the document. One is the arrays and it's the write operation. So arrays is changing any bit from 0 to 1. And the write is changing any bit from 1 to 0. And one very important thing which I forgot to mention here is, when you buy a new card, all the memory bits are set to 1. Now this is the default content of the memory. So if you want to change, or when you do the write operation, you can change this from bit 1 to bit 0. However, a write operation cannot change from bit 0 back to bit 1. To do that, you have to use what is arrays operation. So there are two security levels this card speaks about: the security level 1 and the security level 2. You have to understand the difference between these two. Now, whenever you buy a new card from the manufacturer, they always come with the security level 1. Now, when the card is at security level 1, you've got full access to the card. However, so don't think that when you buy a new card you can just jump in and start modifying the tag. It's not possible. So the manufacturer will always provide the default password of the new tags, and this default password is called the transport code. So once you get the default the transport code, you can access the entire the memory, and this level is controlled by a fuse. So here a fuse means the value of a single bit. Now as long as this fuse has a value 1, the card is at security level 1. When the fuse, or when you blow the fuse, it also means when you change from 1 to 0, we say that the fuse is blown. From that point onwards, the card will enter the security level 2. Here obviously this has got some restricted access. You cannot do everything you could have done with the security level 1. So as I mentioned here, the brand new tag comes with the security level 1 and the card issuer. So after we personalize the card, we can blow the fuse and make this card into the security level 2. And keep in mind, this blowing of the fuse is always in one direction. You cannot switch back to security level 1. So these are some of the theory you have to remember. And with this, probably now I'll tell you a couple of other things which now if you look at this documentation on AT88U, there is a separate section on the memory, the AT88SC102. So these are the commands I will be using. The select card type. This is used to select, tell the reader what type of card we want. We want the card AT88SC102. So the value of that card type will be 9. After that, you have the standard read memory operations where you give the byte address. After that, if you want to write something, you use this write memory card command. The structure is defined here. You are specify the byte address and how many bytes you're going to write. And this is a separate operation for arrays, because now we know write is all about changing the bit from 1 to 0. If you want to change the bit from 0 to 1, you have to do the arrays operation. So there are two arrays commands here: erasing non-application zone with this command set, and erasing the application zone with this command. I'm going to cover these commands in detail when we start discussing about the application zone, arrays, and so on. And this is also a command for erasing the application zone. And finally, we got a separate command to verify the security code. Now this is the code I mentioned about, the transport code. So before you start writing or erasing any part of the memory, the card, you have to verify the password, which is called the security code here. And finally, a separate command to blow the fuses. So there are indeed 3 different fuses, as you can see here: the manufacturer fuse, the issuer fuse, and the EC2, the erase counter to enable fuse. So all these commands are going to say when I start using a tag with you. So when you read the data sheet of AT88SC102 memory card, it looks a bit complex and confusing as well. It could be because my background is more onto the contactless cards with the very simple memory structure, whereas the SC102 has got a different memory structure altogether. And in order to understand this memory card, you have to first understand how the entire card memory has been organized. As you can see here, in order to understand this card, you have to understand what each of these sections of the memory do. And here, most of the memory section are defined using the bits. So like I can see here, it is 16 bits, and the issuer zone is 64 bits, and security zone is 16 bits, and the security code counter is 16 bits, and the code protect zone is 64 bits, and so on. And in order to understand the working of this card, you have to understand 2 tables in this document. So you have to understand how the tag behaves when it is in the security level, security mode 1. And as I mentioned before, all brand new tags always come with the security mode 1 with the default password sent to you by the manufacturer. So you have to understand this table. Now this table shows what what operations can you do on each of these sections of the memory. Take an example of the zones for, sorry, it's called as a zone FZ is a fabrication zone. So if you look at the read, erase, write and compare, so you don't have to worry too much about the comparison because this applies only for the password. The important thing is the read, erase and write. Now what it says is here, take for example this line, when the card is in the security mode 1 and you can read this always, you can always read what is in this the fabrication zone, whereas you cannot erase and you cannot write. So this means the fabrication zone is always read-only memory. So the documentation says this zone consists of the date, manufacturer, anything the manufacturer want to put in there. This could be, a unique ID for the customer. So this is just a 16 bits. So the manufacturer can put anything, and anything that is put here cannot be changed at all. Take one more example here, the issuer zone. Now if you ignore about this R1, R2 and MF, if you look at the SV is the security code validation. It's like the like a password authentication. So when it is not authenticated, that is when it is 0. So think in this way, when if you remember I mentioned about every new card comes with the default or the manufacturer set security code. So when the card is not authenticated, the value of S will be 0. Now in security mode 1, if you're not authenticated with the password, you can just read. You cannot erase, you cannot write. But if I authenticate with the secure code, that is when SV is equal to 1, I can do erase and write as well. So understanding this memory card is all about understanding this table. So I'm going to go through this table now one at a time, and we're going to put a tick saying that, oh, we have understood this. After that, you have to understand a similar table, but when the card is set to the security mode 2. So here, as you can see here, so you know that when the fuse, when the issuer fuse is blown, the card will go to security mode 2. And here, this is always, whether it's mode 1 or mode 2, it's always read only. So FZ is always readable. Look at this IZ. So IZ in security mode 2, whatever the state of the authentication, whether you are authenticated with the security code or not, the issuer zone is always read only. So in other words, in security mode 2, the data in the issuer zone is always read only. You can't write it. So likewise, there are so many other things like this is what, if you're coming from a contactless card, you find it a bit complex. Most of the contactless card are not as complex as this one, because if you look at the present day contactless card, they're all based on the file system, where you speak about the directories and files and so on and so forth. So I think that's all we you have to know, and we are going to cover this. We're going to see this one at a time and you're going to master these tables. You can see I've got my ACR38U reader writer connected, and I got a brand new SC102 card. What you might notice when you insert the card on the reader is you will see a continuous flashing green light, and after some time on your computer screen you will see a message that says your smart card is ready. So initially you might think that none of these buttons would work, so you have to wait that initial time until the card is ready. I'm not very sure why it takes around maybe 30 seconds for the card to become ready. So I'm going to, you can see here the reader is ACS CCID USB reader. Somehow I'm not able to get the name of the reader as ACS 39U USB reader. So this should, if you see this, it's okay, it should work. You connect it. Now based on the ATR, you can look for the ATR by sending this the ATR command. Now based on this, the software is returned to open this screen. Now you have seen this screen a little bit in the previous videos, and this screen is going to evolve over time. Probably in few videos from now you'll see some of the structures will be different. So first thing is, this is you have to follow the AT88U documentation. You have to select the card. Now this is the command to select the card, and for every response, a success response, you will see 9000. Now after that I'm going to hit this button, read entire tag. So I have used a single read command to read 196 bytes altogether. So if you add up all the bits here, you will get 196 bytes. So I'm going to spend a little bit time to explain you this screen. The grid shows the memory structure. On the left side, this is a shortcut for all the zone names. FZ means fabrication zone. After that you can see the bit address. It's from 0 to 15 bits, so which is also 16 bits altogether. And here is the byte addressing. So you have to know the byte addressing because the read and write command provided by the AT88U reader writer requires the byte address, not the bit address. So this is going to be helpful to you. This is the description of the zone. So I think this is the description better suits next to the zone code. Now after that you got the content of the zone in hex. Now if you want to see the content of the zone in the binary, if you hit this column, you can choose what properties you want to see in the grid. Now sometimes it will be useful to see the binary data, and sometimes you can just ignore the binary data. So I'm just going to take this binary out for a while. Now this is what you can see, the zones. Okay, put in other words, so we just inserted the card, we did not do any authentication, no password check. We tried to read the entire memory content of the card. So it looks like you are able to read every zone, and you can see that the value FF means these are the default values of the memory. So a new card will have all bits set to 11. So the first zone, the fabrication zone, has got F0 F0. This is what I got when I bought this this card. So I'm going to try one more card. So what I've done is, this is also a brand new tag, except I have modified some of the zones. So if you can see here the flash, you can see a continuous the flashing light. So I'm going to open this tag, connect, but I did not get this screen because this time, since I've written something to various zones of the card, the ATR did not match the ATR of the brand new tag. So that tells us the ATR what you receive depends on, or it's picking up some part of the data on the card. This time I'm going to choose this tag manually, and you can see it says AT88SC102 not ready yet, so this is going to remove very soon. So select the card as usual, click the read entire tag button. Everything that is not FF I have modified. So if you see here, the value of issuer zone is readable without any authentication, and bear in mind we are working at the security level 1. Now the card has got all the fuses intact, so you can see that it's possible to read the value of issuer zone, and you can also read. I didn't want to modify the security code, the passcode and the passcode attempts. I didn't modify these two. If you look at the CPZ, the protected zone is also readable. Whatever is in zone, application zone 1 and application zone 2 is also readable. I did modify the value of the application zone error key and the application zone 2 errors key, but these two are not readable. So if you see FFF, they're not readable. Not readable, without authentication. So I can read. If you look at the application's error counter, this is also has been modified, so you can read this without any authentication. The memory test zone and the manufacturer zone, and all the remaining bits are the fuses, which I don't want to modify here. Okay, so what you have learned so far is, without any authentication, you can read the data from certain zones. So if whatever you see here matches the documentation, the table 1 of this documentation here. Now our ultimate goal of this video is to understand every rows of these two tables. Now thing is, you may be wondering how I did modify these zones. Now what I did was, when I bought this card, it came with a default transport code. So I have modified the transport code now. So the transport code of this card is A, B and CD. Now I'm going to show you later how to modify this transport code. I'm going to go back. We're going to go back to the first tag I was using. So I'm going to connect. Now you can see that the AT here is the default one. So select the tag. So select the card and hit this read entire tag. If you look at the documentation, there's one zone here called memory test zone, which is both readable, writable, erasable in every security mode 1 and 2. So I'm going to use this to understand the meaning of an erase and a write operation. If you go to this, as soon as you click the rows in the grid, automatically the corresponding tabs get selected here. The test zone, I'm going to write 00 AB. So in order to understand, probably you have to just going to clear this screen. Now I'm going to write 00 AB to this memory test zone. Right, this is a standard PCSC binary update command. If you look at here, you can make out that I have sent the data is 00 AB, and somewhere you got the address. This is a byte 2, sorry, this is 0. Somewhere in here you got the address. I think the address is probably it's 0B. So I want to go through this command just once in this video. So this is the command used to write the memory. It starts with the FFD000. This is the byte address, followed by how many bytes you're going to write, and the the length of the bytes here. If you compare this with the, so in here the byte address is B0 and the number of bytes 2 and the actual data bytes. Now, after the write operation, if you click the link R, so this sends a read, the read memory card command. So again here the byte address is B0 and number of bytes already 02. You can see that, so we have read the byte, the value of this empty Z now 00AB. So we have done the write operation. I'm going to change this time to AB here. Now instead of 00, I'm going to change this as AB and hit the write command. So the write says it's a successful operation. If you try to read, as you can see here, the data still shows 00AB. So even though we tried to write AB as the first byte, the write was not successful. However, you'll always get the response as 9000 as a success response. Now the reason what's happening here is, there are two states, the erase state and the write state, and we have seen that the write operation is changing the bit from 1 to 0 and not from 0 to 1. You cannot write a data that changes the bit from 0 to 1, not possible. And the erase operation is to change the value of the bit from 0 to 1. So in order to do this thing, I am going to use the erase operation. There is a separate erase non-application zone command. We have seen that in this documentation here. The erase non-application zone, it's the instruction code is D2 followed by the byte address, and you just have to specify the byte address here. That's all. And the memory length is always set to 00. So this looks like, what if I want to erase more than 1 byte? Now here the documentation says the erase operation is always in 16 bits. So you can, we are going to come back to this in the later videos. So I'm going to select this empty Z and I'm going to hit this erase. Now this is the erase command and the address is B0 and 00, what the manual says. I have done that. If you try to read now, you can see that all the 16 bits of memory is set to FFs, all bits as 1. So now I can write whatever I want. I wanted to write AB and AB. So what you have to keep in mind is, if you are trying to change from bit 0 to 1, you must first erase the memory content and write the new data. Now that's how the erase and write works, and everywhere this is the same principle. The write can change from bit 1 to 0 and the erase can change from 0 to 1. So I'm going to quickly go through and see what write operations can be done without any authentication, without any password check. Try to write it to the fabrication zone. We have seen in the previous videos you cannot write or erase. So the best thing for me is to remove this these two buttons. So I've got here so that you can try and see that these operations write and erase are not possible even after the card is authenticated. Go with the issuer zone. Now this is a zone used by issuer to record probably the customer ID or a unique ID for the card. Now keep in mind, if you come from the contactless cards like the Mi Feral Trolite or any ISO 15693 card, every card comes with a unique ID called UID. So that concept is not here in this secure memory card. So I'm going to write all zeros. I can't do like this. So to write it, you need Probably I could have just tried to change the last byte here. So I'm going to write. Now the write is successful. That's what the software says. If you try to read the data back, now we are not able to change. So this shows you cannot write to issuer zone without any authentication. So I don't want to touch this the password. This is a security password and this is a password attempt. So if you have seen my videos on SLE 4442, you will come to know how important is this and how risky is to play with this the security code attempts counter. So I would not want to touch these two at this stage. The code protected zone, the documentation says this is always readable but writable only after the proper security code validation. So I'm going to just try to change the last byte to 0. Write, I'm going to read, so you can't write here also. The application zone, try to change the last byte 0 and write and read again. You can't change the application zone 1, and you can see if you can modify the application zone 1 erase key. Try to change this the last with the zeros and give a write. So read, so even you can't change that. Likewise, just going to quickly go through this write operations and read. So you can't write to application zone 2. Now these two zones, you can treat this card as a multi-application card. You can have one application using zone 1, another application using zone 2. Probably this could be like a loyalty card, and this could be your like a transport card, so on. And check with the erase key for zone 2. Now this is a difference between erase key for zone 2 and erase key for zone 1. This is 6 bytes and this is 4 bytes. So it's here. Write and a read, it's not possible. And erase counter, you can treat this something similar to the password attempt counter, not that serious though. You can play with that. So if you look at the documentation, it says, see, by default you can erase this zone 2 any number of times. However, you can limit the number of times one can erase the application zone using this counter. So there are 128 bits altogether. Probably in my next video I'm going to bring the size column here as well, so you don't have to go back to documentation for information like the number of bits for a zone. Now here in fact I would treat this very similar to the attempt counter, where each bit refers to an attempt. So there are 128 bits altogether. Now I can configure the card to let zone 2, see, this applies only for zone 2. So zone 2 can be erased only 128 times, and this is controlled by a switch like a fuse, which is this one. Okay, the erase counter enable fuse. Now if this is blown, that is blown is changing from 1 to 0, then this counter will be used every time you erase the application or 2. One of the bit will be erased here as well. So you can do 128 times. After that you cannot erase. You can think about so many applications that requires this concept. Now the memory test zone, I don't mention that because this is like a playground, developer's playground. You can read, write, erase, do whatever you want to do. Manufacturer zone, I'm going to try and reset to 0 0 and say write. Now can we write? Read back? No, you can't write that without any password authentication. This is a very interesting called block write and erase. I'm going to give a small theory about that in this video, and we're going to see it working later. Using this, if I write, so the entire most of the zones can be cleared or returned to 0 by writing a single bit here, and most of the zones can be erased by erasing this zone. Now this is an interesting thing, and you have to be careful, this will going to erase even the security code as well. So it's a nice feature. We can use it for application. The manufacturer fuse, and this is not this, we can't. Let me try whether you can. I don't think. Okay, yeah. So you got a write operation. There's no meaning for a write operation here. So I have provided so that we understand, practically see that write has got no meaning. So you can only blow. There's no unblow command. Now manufacturer zone, manufacturer fuse. So try to. Now I think probably this is disabled. Now if you try to, I've seen this, if you cannot modify this thing at all. You can modify or you can blow this thing only after the secure code verification. So likewise, let me check if you can. I'm not sure whether this is set to, oh, these are set to read only. Okay, now sure thing, yeah, no. Okay, and I think this just a quick overview of what you can read, what you can't read in this video. So I will continue from where we left, okay, in the next video. Thanks for watching.